So we got a cube, right? We got some water, we got a cup. Here are the masses, the cube, the water, initial temperature of both, and they're at the same temperature. The mass of this ice right here, and then its initial temperature, which is at its melting point, but it hasn't started melting yet. It still has to go through that process. We need to find the final temperature, right? Everything's gonna be set equal to 0. We're gonna have the Q of the cup, the Q of the water. For the ice cube itself, there's gonna be 2 processes. It's gonna melt first, and then once it's melted, it turns into water, and then it's gonna get to like a final temperature. So we'll say I am for melting. Let's place it over here. I am melting. Once it's melted, it'll be the regular, just ice. It'll just be water. Now for these 3 right here, we're gonna use the regular formula, which is Qm. Then you have a specific heat and then the change in temperature, which this can actually be broken into temperature final minus temperature initials, which they're all given here. So that's gonna be for these 3. For this one specifically, we're just gonna have mass and then the latent heat of, for this one, I think it's the latent heat of fusion. Lastly, you just substitute all your variables into here. Unfortunately, we're not working with C++, so we can't just like do things. You gotta like actually compute them by hand. Anyways, substitute and you get your answer, set it to 0, solve for TF.